Testing, testing. Can you all hear me? Let me know in chat if you can hear me. Nice. Welcome to Free GMAT Prep Hour, April 14th, 2021 edition. Yeah, I had to read that off the screen. I cannot remember what day it is. All the days just kind of blend together. Welcome. Looking forward to spending some time with you all. And if you're watching on YouTube, thanks for checking the video out. Take a look to the right and see if there are other videos in the series. We have a lot of videos on this channel. Hopefully some of them provide some value to you. Excellent. If you are here in the live webinar, just go ahead and let me know in chat how you're doing. How about everyone in chat tells me where they are right now? Toronto, cool. Chicago, oh, a couple Chicagos. Boston, Montreal, India. Thanks for waking up early or staying up very late for Free GMAT Prep Hour. It's cool to get such kind of a diverse audience at these things. Tokyo, Australia. Wow, this is awesome. I hope you find this hour valuable. I have some plans to chat with you this hour about a couple of things, but first of all, just some ground rules. If you have questions for me, I'll just go ahead and say, let me know in the chat box. I have that pulled up and it's easy for me to access the chat quickly and monitor it as I'm talking and asking questions. Additionally, if you want to ask questions kind of privately, just go ahead and send it to just me, just the panelists. You can submit a question in the Q&A box, but I probably won't be checking that as regularly. Awesome. Before we dive into the content of the day, just a reminder, a couple other free resources coming available, and I actually think I need to add to this list. So I will say that you are always welcome to come check out session one of one of our classes, our GMAT full course offerings. Come to session one, see if you like it. Check out kind of who the instructor is, and if you like the instructor's teaching style and you like the vibe, you can also check out a preview of GMAT Interact, which is our kind of more self-guided study course, and you'll get the first 5 lessons with a free trial, I believe. I also invite you to take one of our practice exams. The first practice exam at Manhattan Prep is free. You can get some good data and try to figure out maybe what you need to work on at the beginning of your studies. I believe we're adding some more free things coming up, so maybe there'll be an update with the next Free GMAT Prep Hour, but I think there's going to be some more stuff that we're offering for free very shortly, so that's something to look forward to. I have another topic-specific lesson today. Kind of came up tangentially in a previous one I did a few months ago. I figured it wouldn't hurt to dive in a little bit deeper into functions. Yes, I was going to call this session something like, you can't spell functions without fun. And then I realized, like, you also can't spell functions without no fun. I was like, maybe I shouldn't play that game. But we're going to talk about functions because I think function problems can seem off-putting or intimidating or both. And so I want to kind of start off with some basics of functions and then pick up and kind of start dealing with some tougher concepts related to functions. I have a bunch of problems. I'd love to get through them all. This might turn into free GMAT prep hour and a half because I just do want to get through all these problems. So if you have to tune out after an hour, all good. Free GMAT prep sesqui hour. Yes. So we are going to go over what a function is and try to talk about like the mechanics of a function because they do seem a little strange. Some things to be thinking about when you tackle a function problem, and then scaling this up to some harder problems. Yeah, question came into chat. When will this be up on YouTube? That's a great question. Usually within the week. It kind of depends. Sometimes they're up like in 2 days. Sometimes they take a little bit longer, but generally within a week. No promises. Good stuff. Let's go ahead and just start with the problem. I'll ask you to kind of submit some answers to me. So why don't you go ahead and turn your chat to just the panelists so you're not blasting absolutely everybody with your answers when you have them. I'll give you about 90 seconds to think through these two mini problems. I know they're not multiple choice, but we're just going to work on function mechanics right now. If you sent me answers already, I'll give you the some thumbs up here. Another 15 seconds or so. All right, good stuff. That's been about a minute and a half. We will go ahead and move on. If you're still working on this online on the video, on YouTube video, go ahead and just pause it here. That goes for like any time in the lesson, right? If you ever just need a little bit more time to think about something, go ahead and pause the video before I ruin everything for you. I am a ruiner of things. Let's talk about what a function is. Okay, so actually, let me get some ideas in chat. If you had to describe to someone what a function is in math, how would you describe it? Yeah, if you're raising your hand, go ahead and just like let me know in chat. Kind of like that idea. Go ahead and type some of these out. Series of operations, replacing a value of X. you just put in the inputs and it spits out a number. Yeah, these are all pretty good. I like these. I like this idea of like, it's a machine, right? It's a machine where you put something into the machine and it spits out maybe something different. Maybe it spits out the same thing, who knows, but it does something. I like this idea of the machine that does work. I think of a function as kind of like a dynamic operator, right? A change is done or a transformation happens. I like to think of a function as like, yeah, you put something in and that thing you put in is transformed and it spits out maybe something else. Maybe it actually does a bunch of transformations and it ends up being the exact same thing as where you started. But I like this, a specific transformation or maybe a series of transformations that you might do to an input. So I like to kind of think through, like talk through functions as I go, because I think like talking through this transformation really helps make the function less abstract and more real. So I put in X and I do something very specific to it. I transform it in this specific way. So the specific function that we were working with on the previous slide is f of x is x squared minus x minus 6. And what I want to say here is like, there's some function based on what x is. And in this case, this specific function, what it does is it squares x. That's like the first part of the transformation. And then once you have that, you subtract an x from it. And then once you have that, you subtract 6 from that. So I just kind of like talking myself through this. Right? In this function, I'm going to square what x is, and then what? Then I'm going to subtract x from that, and then I'm going to subtract 6 from that. I kind of rehearse it. So let's figure out what's happening here. some other definition kind of came into chat, and it has to do with substitution. Yeah, like instead of you thinking about X here, you're just going to replace X with 7 or substitute 7 in for X. So what we're going to say is f of 7, not f of 2, is I'm going to take this input and I'm going to square it. Okay. And then I'm going to subtract whatever X is. So X is 7, subtract 7 from that. And then finally, I subtract 6 from that. And then we just compute this. Now we have numbers. Numbers are like more friendly than letters and variables. And so we have 49 minus 7 minus 6. 49 minus 7 is 42, minus 6 is 36. So f of 7 in this particular operation is apparently 36. We can do the same thing for f of -3. Now, when we see x here, we're just going to substitute in -3. Now, a couple things we have to be careful of here is to remember that in the original, x gets squared. And so we have to make sure that we don't just write this on our page, but the entirety of what x is -3. That input gets squared. And there's a difference between getting 9 at this stage and -9, which can make a huge difference. Then we are going to subtract what x is. And remember, x in this case is -3. So we have to subtract -3. And I think it's very easy in here to just subtract a +3. Remember, the value of our input is going to completely substitute for our unknown, and that includes the negative signs. Finally, we're going to subtract 6 from that. -3 squared is 9, minus -3 is actually +3, minus 6. 12 minus 6 is 6. And here are our answers for these first intro questions. So one thing I like to think of when I'm dealing with function problems is I'm going to talk myself through the transformation. Right? And this is like much more important when the functions get more and more complicated. But rehearse through the function once without actual variables or numbers. Just kind of tell yourself what's happening, what the transformation is, or what the transformations are in a particular problem. Cool. Good stuff. All right, let's move on. Next problem. I'll give you 2 full minutes to think through this one. It's been a minute and a half. It's been 2 minutes. I'm going to give you a little bit more time if you feel as if you are getting close. All right, if you're not close, go ahead and give me your best guess. If you feel like you're pretty close, go ahead and take another 30, 45 more seconds here and finish. All right, that has been about 3 minutes, which I would say is probably about as long as you'll want to take on any problem on the quant section if you have standard time. So you can see that function questions can get a lot harder very quickly. Had a lot of pretty quick responses on those first 2 intro problems, but this one, still a function question, a lot fewer responses, especially like in under 2.5 minutes. That being said, I still think we'd like to approach function questions in roughly the same way. One good thing is to just talk ourselves through what's happening in the problem. So we have this function that measures apparently like the position of some object. I don't know if that object's been thrown or whatever, but the position of some object is measured by this function, and the function is based off of what t is. Okay, it's going to depend on how long something has been in the air, I suppose. Here's what the function does. We are going to take whatever t is and multiply it by r. Then we're going to take whatever t is, square it, multiply it by 5, and subtract that from our first value. And then before we're done, we're going to add b. Now, it tells us later that r and b are constants, but we still don't know what they are yet. Okay, there's a lot of kind of unknowns. However, we are given some very important information here. We are told p of 2 is 41 and p of 5 is 26, and we are going to have to use these if we have any chance at solving this. So suggestions in chat. What's the first thing I should do at this point? Well, maybe the first thing we should do is decide if we are going to proceed with this problem, right? If you are reading this problem and you were kind of like, I have no idea what's going on, maybe this is a good problem to bail on and save some time, right? And save that time for questions you might feel more secure with. That time would be useful. Great, I've got a really good suggestion in chat here, and it's similar to what we did on the previous problems. We're just going to substitute, right? P of 2 is 41. So what P of 2 means is I'm going to substitute 2 in every time I see T. So P of 2 is going to be R times T, but T is 2 in this case. I am then going to subtract from that 5 times T squared. But in this particular problem, I'm substituting 2 in for T. So 5 times 2 squared. And then I'm going to add B. And apparently that is equal to 41. All right, so let's clean this up a little bit. Look at this in like a slightly different format. R times 2, I'm just going to call that 2R, minus 5 times 2 squared. 2 squared is 4, times 5 is 20. So 2R, then I'm going to subtract 20, then I'm going to add B, and I'm going to get to 41. This tells me that when I add 20 to both sides, 2R plus B equals 61. And so all we're doing here is we are just substituting, right? I like talking myself through what a function does, and then I'm going to substitute in. It tells me, in this case, when T is really 2, I churn out 41. This transforms this into 41. Let's see how that really works. And this is what we get. So we're going to do this with our other function value, P, when I substitute 5 in for T, gives me 26. Sorry, just checking out on chat. Question came in chat here. Let me just go see if I can address it really quick. Question came in on chat. Could I divide? Oh, I just turned everything upside down. We're just gonna like delete that and redo it. Question came in on chat. Could I divide this equation by 2? Sure, of course you could. You can pretty much do whatever you want. Like you could divide by 2 at this point if you want. You could add z to both sides. I don't see z anywhere, but you could add z to both sides. You could multiply everything by pi, as long as you do both of those operations to each side of the equation. So you could divide by 2 here. If you did that, you would get r plus b over 2 equals 30.5 or something. That's mathematically fine. I don't know if it's going to help at all though. So it is possible, but maybe not advisable. Yeah, I mean, how do you know it's advisable? I don't know, experience, but we have like a pretty clean equation here. And so I would just say this clean equation, let's go ahead and leave this and see if we get another equation that we can work with. But certainly you could isolate R, isolate B, do a number of other things. I'm not really sure what's going to happen, but I have an equation with 2 variables, so my options are a little bit limited right now. Let's tackle the second value, P of 5 equals 26, and then see if that gives us any ideas. So P of 5, which would just be R times 5 now, minus 5 times, well, normally it's 5t squared. I'm substituting 5 in for t. So it's going to be minus 5 times 5 squared. Wherever I saw t, I'm just going to write in 5 and then plus b. And this is equal to 26. Let's clean this up, kind of similar to how we clean this up. R times 5 is 5r. 5 squared is 25 times another 5 is 125. Yeah, 5 cubed, 125. We're going to add b. And apparently we end up at 26. I think I can add 125 to both sides here and just get 5r plus b is 26 plus 125 should be 151. And now we have 2 pretty good equations. And I'm going to say they're pretty good because of how they relate to one another, right? These 2 equations are such that we can now stack them. Okay, I'll probably just type this out because my typing is cleaner than my writing. But I know 5r plus b is 151. I also know that 2r plus b is equal to 61. You could substitute at this point, but I think it's actually cleaner to just subtract the second equation here that I've got from the first one. And what that's going to allow us to do is cancel out the b's, cancel out 2 of the r's, 3r is equal to the remaining 90. And if 3r is 90, then a single r is 30. All right, r is 30. Now I can choose whichever equation I want. Maybe I'll just plug that right back in here. R is 30, so 5r is equal to 150. And if 5r is 150, that means b needs to be an additional 1. So there is like quite a bit of algebra that has to happen here, but the way into the algebra is to first just substitute. All right, let's go ahead and write these down. R is 30, B is 1. This is going to be critical because now we have this function equation and I can get rid of 2 of my 3 letters. I know P of t is 30r or 30t minus 5t squared plus 1. And so when t is 4, 30 times 4 is 120. T squared would be 16 times 5 is 80. And then we're still going to add 1. 120 minus 80 is 40 plus 1 is 41. Answer D. If you got answer D here, great job. Whether you solved it like this or you guessed. Maybe the best way to get answer D is if you guessed immediately rather than spend 3 minutes on it. Let me pause here and just see if there's any questions from the group. As you can see, these problems can scale up in difficulty pretty quickly, but the mechanics of how we approach these problems is largely the same at the smaller level and at the higher level. I want to talk myself through the function. What is actually happening in this function? Let's make it real. And then let's substitute in some values in, right? Substitute some values in. I'd say this is a hard question, quite hard. This is actually from our advanced quant book. So towards the end of the advanced quant book in the practice sets. So one other kind of takeaway I might have with this problem, and we've mentioned it a couple times, we even mentioned it earlier, is when I see a function problem, like function problems are often best tackled by substituting. Okay, and that's really what we're doing here, right? We're substituting 2 in for t, or we're substituting 5 in for t, or even in kind of these earlier problems, right? We're substituting 7 in for x or -3 in every time we see x. So remember, functions are often best tackled with substituting. Nice, let's go on to the next one. Give you 2 minutes here. It's been 1 minute. It's been 2 minutes. If you have an answer, go ahead and let me know what you're thinking. Ooh, these are starting to be the problems that like make me a little anxious. What do we have in the answers? All the answers are like Z's and N's, which is weird because I started off by talking about F's and A's. Where are the Z's and N's coming from? I like numbers, right? I like numbers. Letters are a little stranger for me in quant. They're less real, they're more abstract. And so this problem presents like lots of letters. Oh, I made this question up. Yes, I made this one up. I made a lot of these up, for better or for worse. So I think if you're kind of like turned off on this problem because there's like a lot of letters, I think one thing we could do is just talk ourselves through the problem again by substituting in a real number. Okay, so if we have f of a equals 3a plus 1 over 4, I'm saying, I'm going to triple whatever a is. Then I'm going to add 1 to it. And I'm going to divide it by 4. All right, let's figure out what f of 9 would be. Everyone take 30 seconds and try to tell me what's f of 9 here. Yeah. Be quick. Stuff. If you sent me an answer, thumbs up. Not 7 factorial. That's a very big number, but 7. Yes, it should be 7 here. Oh, a question came into chat. I think in B, it should be 3z minus 1. Actually, I did that on purpose because like this would be an easy one to get rid of, right? What's n squared in terms of z? It has to be based off of z. Okay, we'll get to that in a moment. So what we're going to do for f of 9 is we're just going to replace the 9 almost looks like an A. What we're going to do is we're just going to replace the A with the 9. We're going to substitute. So what we're going to do here is just say not 3A plus 1, but 3 9s plus 1 over 4. And everyone's telling me, hey, that's 27 plus 1 or 28 over 4, which is 7. And I would say, like, if you feel fluent with this, then we're not far away from being able to get this problem. Okay. Because I don't want to know what f of a is or f of 9 is. I need to know what f of n is. Okay, so I want to take a moment here and just figure out what would you do, not with f of 9, but f of n. Give you a little bit of time to think about that. JD, tell me how you got that. All right, so what we're going to do here is instead of replacing a with 9, we're going to place a with n. So it's not 3a plus 1, but it's 3n plus 1, whatever n is. And I'm going to divide that by 4. Cool. Well, I can't really like do anything with this because I don't really know what n is, but I might not need to know what n is. I'm trying to figure out what n squared is in terms of z. And this language can also be a little strange, so we should talk through what it means. What is n squared in terms of z? I want to say n squared is something. N squared is something. And then over here, this will have some z stuff in it. This is very technical, but I'm going to try to get n squared isolated. And then the other side of the equation might have some z things floating around. So if you understand this language, that there's going to be n squared by itself and some z things on the other side, then you can get rid of answer B. Right? That's like an easy elimination because it's not in terms of z, it's in terms of n still. And we can just go ahead and knock out answer B. See if I left myself enough room here. So I know f of n is equal to this, but I also know f of n is equal to z. So what I'm going to do is I'm just going to cut out the middleman here and just say, well, if z is equal to f of n, and that's equal to 3n plus 1, then really z is equal to 3n plus 1 over 4. Let's go ahead and write this over here to clean it up. And now I just need to go find n squared. So let's go one step at a time. Let's go to figure out what n is, and then we can square it. 3n plus 1 would be z times 4. I'll multiply both sides by 4. Now I will subtract 1 from both sides. Now I'll divide both sides by 3. 4z minus 1 all over 3. And that means when I square it, I will have indeed z stuff on the other side. Go ahead and change colors. Just say, n squared apparently is equal to 4z minus 1 all over 3 squared. Sorry for cramping up all the room here. And so now I just need to find an answer that has 4z minus 1 all over 3 squared. And it might not be in that exact form, but answer D is equivalent. Yeah, the 3 squared has just actually been applied and turned into 9. So this one's answer D. So I think there's a couple ways to move through a problem like this. Just remember that we are replacing A with another letter. And while that can be a little bit strange, one of like the halfway steps we can use to kind of connect that gap is by just plugging in a value as an example. Now, the other thing we might be able to do here is actually just pick numbers, because this problem doesn't actually tell us what n is, what a is, what z is, or anything. So we actually might be able to use this strategy of choosing smart numbers to move through a problem like this. And so what I'm going to do is I'm actually just going to take some credit here from my previous work and just remind myself that Zoom used to have this function where you could just like delete everything with your cursor, select everything and delete. You can't do that anymore, or at least I'm not smart enough to figure out how. What we did here is we just said, what if 9 were A? Well, the other thing I could just say is like, what if 9 were N? If 9 is N, and it tells me f of 9 or f of n is 7 in this case, then I should be able to figure out that n squared is 81. And now we could just try to like plug in our values, right? If n squared is 81 and f of n is 7, well, that means because z is f of n, z is 7. And so I could go hunt through here and try to find the answer that gives me 81 when I plug in 7 for z. If you haven't seen one of our earlier videos, I think Whit Garner did it on choosing smart numbers. This would be like a good video to watch and see like how this process works. But because this question doesn't have any actual specific values, you can just make up your own specific value and push it through the problem. And indeed, if you plug in 7 for z here, 4 times 7 minus 1, which is 27. We'll take all that squared, divided by 9. I could maybe convert all of these to powers of 3. This is 3 to the 3rd squared over 3 squared. That's 3 to the 6th over 3 squared. That is 3 to the 4th. And 3 to the 4th is 81. So answer D does check out. I don't know if I would recommend choosing smart numbers, but it's interesting to note that one could do it here. So if I see a function problem, I'm going to just substitute, even if that means I have to substitute letters instead of values. Okay, so function problems are all about substituting. And if I see a function problem that just has like lots of letters in it, then that's a good point. I'll come back in a second. Then I'll kind of talk myself through it by submitting substituting a value in instead of a letter. Comment came in chat. Let's see if I can bring this back. Comment came in chat. I have not verified this, but I believe it's true. If I pick n as 1, then D works, but A also works. Yeah, let's see what happens. If A is 1, then f of 1 is 4 over 4, which is 1. So if n were 1, then z would be 1. And n squared would also be 1. So like everything is 1. And indeed, when you plug in z as 1, and you plug it through, like you get 1 as an output. I feel like I'm saying 1 a lot. This is why when you pick smart numbers, it's often not a great idea to pick numbers like 0 and 1, because they often lead to kind of redundancy or repetition in answer choices. Yeah, because when you multiply something by 1 or add 0 to something, nothing really changes. And we're into like transformations here, things changing. And when you use 0 and 1, there's a risk that some things won't change the right way. And so that's kind of what happens here. When you square 1, nothing happens. Good comment, Rohit. Love it. Let's go on to the next problem. Give you 2 minutes here. been just over a minute. All right, that has been 2 minutes. 2 minutes. Oh, who has raised hand? Yikes. If you raised your hand, just like hit me up in chat with your question, or maybe it was an accident. All right. The triangle. What is the triangle? Don't worry, you did not miss that day at school. No one's expecting you to know what the triangle is. Don't be like, Jeff never told me what the triangle was. I don't know what the triangle is until I get a little bit further in this question. I suppose like if you've taken like lots of calculus, you're an engineer or a math major in undergrad, you maybe have seen the upside down triangle actually used as an operator in calculus, vector fields and stuff. But that is very far removed from the GMAT. So they're gonna have to tell you what the hell the triangle is right here. And the definition will typically follow the introduction of the symbol. This triangle is an operation and is defined by this. So I'm just going to make sure I talk myself through this. Now, in this case, there's two unknowns, right? X and Y are like being transformed together. And I just want to make sure I understand what that transformation is. It apparently is this. When I squish together X and Y this way, what I'm doing is I'm doubling the first value and I'm dividing that by the second value's square. All right. And so if this is at all confusing, maybe you could just kind of walk through an example. What is 3 triangle 4? Well, I'm going to double the first value. So double 3 is 6. And I'm going to divide that by the second value's square. So divided by 4 squared or 16. And so this would be 3/8 in this instance. Cool, I feel like I understand the triangle. Let's go take a look at what this is asking me. What's the value of, oh my God, there's 2 triangles. Okay, so when we see multiple triangles, all we're gonna do is remember our order of operations. We can't do them both at the same time. So we're gonna have to figure out which one to tackle first. And this one on the left is within some parentheses. So you remember your order of operations, tackle the stuff in the parentheses first. So let's just tackle this bit. -4 triangle 2, I'm going to double the first thing. That's what this triangle thing tells me to do. I'm going to double the first thing. So it's 2 times -4. And I'm going to divide that by the second one's square, which is 2 squared. 2 times -4 is -8. 2 squared is +4. And so this gets me -2. So -2 is the value of this blue box for right now. And so what I can do is I can now just say, I'm going to substitute -2 in for that blue box. I already like did the first half of this problem. And so this is going to become -2 upside down triangle, -2 again. And so we repeat the process, right? Remember, the triangle operation is double the first thing. So -2 doubled. And then divide it by the second thing's square. Yes, it's -2 squared, not -2 squared. You know, the pause there is might hurt you. -2 times 2 is -4. -2 all squared is +4, and that means this all turns into -1. Answer C. Answer C. If you missed this problem, I think this is definitely worth assessing where you missed it and why you missed it. This is like a classic example of you either miss it because we don't understand what the triangle operation does. So we just kind of want to iron that out. All right. And remember, like we did not know what the triangle operation did until we got to this part of the question. So there's nothing that the GMAT is expecting you to know yet. But another way to miss this problem is to drop a negative sign, right? Not fold in a negative sign into one of the operations. And if that's why we're missing this problem, that is very fixable. And so we just want to figure out what we can do to fix it. Maybe it's write more parentheses when you substitute in. Right? It's very easy to kind of drop a negative sign when you're substituting stuff in. Remember, the negative is attached to your input. Okay, so that's like the very start of your order of operations. All right, so weird symbols, don't panic, right? It's still just a function problem, and they have to tell you how the symbol works, right? There's lots of weird symbols out there. You don't need to know what any of them mean before you get to the exam. If there's multiple variables, I'll just understand that, hey, that symbol is just substituting multiple variables in. I still want to kind of talk through the problem. So what we've done on those easier problems, I still want to build up from those fundamentals. Yeah. All right, I have 3 more problems for us to do. I think they're all reasonably difficult. The first one is from an official practice exam, and the next 2 are ones I made up. Let's go to question number 5. Give you a couple minutes here. It's been 1 minute. Oh, that is 2 minutes. That is 2 minutes. This one's tough, huh? It's a business decision if we're going to finish this off, right? Or if we're going to guess at this point. All right, that's 2:15. If you're watching on YouTube, guess here or pause it. Give yourself some more time. So what is the star in the circle? Guess what? It doesn't matter, right? It is not something you've ever seen before, or if you have seen it, it probably doesn't mean the same thing here. It's going to have to tell you what it is, and I want to talk myself through it. Okay, it's some kind of transformation of 2 things, of A and B. And A star B is this. I'm going to add the 2 items, first plus the second, and then I'm going to subtract their product. So it's like, if I were saying this to myself, it would be like sum of the things minus product of the things, right? Again, not very technical, but I just want to like understand this function in my own words, right? Okay, add these 2 things and I subtract their product. All right, which of the following statements must be true for all integers a, b, and c? Okay, so I'm going to look at probably whichever one looks easiest first, and that is not going to be number 3. Okay, so I'm just going to like pause on number 3 because I'm not sure I'm going to be able to do this in the amount of time I have. So I'll take my chances with 1 and 2 first, and then we'll see how we do from there. Let's go look at number 2 first. It only has 1 letter in it. Okay, let's go look at number 2 first. 2 says a star 0 equals a. Okay, so let's reflect how this is going to work with the function. I'm going to sum the things and I'm going to subtract their product. Okay, so the sum of a and 0. The sum of a and 0 is a. And then I'm going to subtract the product of those things. All right, so I have to subtract the product of a and 0. Well, anything times 0 is 0. So I'm going to subtract 0. So I guess a star 0 is just a. Interesting. Does that equal a? Yes, it equals a all the time, which means this must be true. There are no exceptions where a star 0 will not equal a. I'm going to give Roman numeral 2 the check mark. All right. Ooh, I'm going to update my answers. Answer A is out because I know Roman numeral 2 works. Answer D is out because I know Roman numeral 2 works. Nice. Let's go take a look at Roman numeral 1. A plus B minus AB. Well, they already told me what A star B is. That's convenient. All right. It tells me A star B is A plus B minus AB. I'm going to take what they give me. They don't give me a lot of stuff sometimes, so I'm very lucky here. I need to figure out, does that equal B star A? Well, again, I'm going to sum the things, okay? The sum of B and A. And I'm going to subtract the product of those things, minus BA. Well, guess what? AB and BA are the same thing. So I could just rewrite this as AB. And double guess what? B plus A is the same as A plus B. So I could just like actually reorder this. And it's literally the same thing on the left side as it is on the right side. So this always has to be true. Roman numeral 1 is also true. And now I can eliminate answer B. I know 1 and 2 are true. And now we're going to take our chances with number C, so, or with option 3 here. So this is going to be like a business decision. Do we want to spend more time and work on Roman numeral 3, or do we not? I mean, you've already raised your chances from a 20% random guess of being accurate to 50-50. Increase of 30% of expected value here. That's pretty good. Is it worth going from 50 to 100%, spending a lot of time on Roman numeral 3? That's going to be kind of up to you and dependent on what your strengths are, how quickly you feel you can do the algebra accurately, and maybe how much time or energy you have left on the section. I will tell you, in this case, if I had to guess, I would probably just guess that Roman numeral 3 is going to work because it seems like confusing in such a way that's going to be like interestingly identical. The GMAT is often using these like tricks where something looks really complicated, and the GMAT kind of hopes like you say, that's too complicated, I don't know, and you kind of automatically assume that it's not going to work. And so just because I've seen the GMAT like do really tricky things like this enough, I might just lean towards just giving Roman numeral 3 the benefit of the doubt, but I don't feel 100% about it. Roman numeral 3 actually is true. Okay, if you do all of the algebra, you will find that they end up being exactly the same. All the terms reproduce. There's like 7 terms on each side of the equal sign, and they're all identical. They're in different orders, but they're all identical. So I'm not going to go through that here just because I think no one really wants to see me like doing a bunch of distribution. That's not it doesn't make for good TV, but it's worth just like writing this down and proving it to yourself later that it does work. Yeah. Yeah, question, a comment came in. If we substitute 0 in for b, it'll work. Yeah, but it's supposed to work for all integers. So just because it could work for an integer b doesn't mean it has to work for all integers b. So there's a difference between like must be true and could be true. And saying it works when b is 0 just tells us that it could be true. So yeah, how do you fight your brain when you know you can solve it, but you kind of have to like tell yourself maybe it's not the best use of your energy and time here? It's going to be dependent on a lot of things. You have to be very honest with yourself with like, do you actually think you can do this efficiently right now? And if the answer is no, or do you think you can do this confidently right now? The answer is no, it's probably not worth your time. The other thing is, if you're saying you can't do it efficiently or confidently right now, you're kind of admitting that this problem is like relatively difficult. And that means that it probably doesn't matter as much because the difficult questions the GMAT kind of expects you to miss, but the easy questions are the ones like you really kind of have to get right on this exam. Yeah. All right, so lots of good questions in here. Should you try to figure out if the star means plus, minus, multiple, multiply, or divide? No, because apparently the star doesn't mean any of that. Right? The star means it's like this weird operation that we've never really come across. The star tells you you're actually doing a couple operations. You're doing three things. You're adding the things, then you're multiplying them and you're finding the difference between those. So we don't want to like think that this particular symbol tells us to add, subtract, multiply, or divide. We have to have an open mind. It could tell us to do like lots of other things. Just as the triangle in the previous problem told us to double the first thing and divide by the square of the second. So they're sometimes very complicated operations. Yeah, so there's some questions coming in about, for the same reason that Roman numeral 1 worked, isn't that why Roman numeral 3 should work? I'm going to say if that is the case, it is not obvious to me, right? Like, what is implied in Roman numeral 1 is like, yeah, like both addition and subtraction are commutative, which means it doesn't matter which term you do first or second. Or sorry, both addition and multiplication are commutative. It doesn't matter which thing you do first. Like a plus b is always b plus a, and a times b is always b minus a. I don't know if that will work in Roman numeral 3 because of the way the parentheses are happening here. I will say if there is that kind of property of like commutative properties, associative properties, like it's not obvious to me at all. Maybe someone cleverer than me might be able to kind of see through that, but I am not cleverer than me. Yeah, cool. Let's just remind ourselves here. When you see multiple symbols, so if you're going to do Roman numeral 3, make sure you start from the symbol inside the parentheses and remember your order of operations here. All right, it has been about an hour, so if you have to run, totally cool. I do have 2 more problems I just want to share because I like getting these things up onto YouTube for people to get more stuff out of these videos. Feel free to stick around if you have to run. Thanks for joining. We'll go on to the 6th question. The 7th question I think is pretty tough, so you could just fast forward to that if you're on the video and you want to look at it. I'll give you a few minutes to think about this one. It's been 1 minute. Sorry, let that one run a little long. That has been 2.5 minutes here. Oh no, I'm not even sure what this question is asking. It might just be a bad question because this is another Jeff Vollmer original. So I apologize if this question is unclear. Yeah, I spent a lot of time trying to figure out how many people wait in line for roller coasters. How can I model that? Also, like, when do amusement parks close? So I don't know. I guess it depends on. Are you in Florida? The amusement parks are open. If you're in most other places, they're not open. All right. Yeah, some questions coming about like how even to get started here. Would I have to like, I mean, can I plug these in? Can I plug these in and like do the math and then figure out which one's the smallest? That is possible. Unfortunately, I don't like really want to do that calculation because like it's a lot of work, like squaring potentially like decimal numbers, multiplying that by 8.3. Like, Jeff, why'd you pick such an annoying number? Because I'm a jerk. There's a lot of calculations to do here. So what I want to recognize in this problem is that we're looking for like when you could have the most possible people in line. I'm interested in knowing that, so I know not to go to that ride at that time, right? But like, at what time will the roller coaster have the most people in it? And so what I'm trying to do here is I'm trying to like maximize the value of this function. Okay. How do I maximize the value of this function? Well, let's see like what goes into this function. I have some stuff tied up with t. I take whatever t is, subtract that from 5.5, square it, multiply that by this annoying number, and I add 300. Well, the one thing that like isn't affected in this formula is the plus 300. So like you're always going to deal with plus 300. There's nothing you can do to avoid adding 300 at the end of this problem. So I want to focus on this, right? I can't make 300 bigger. 300 is always 300. So what I want to do is think about like, how do I make this component, this sub value of my function as large as possible? So maximize the value of this function means like maximize this value within the function. How do I make this thing as large as possible? Let's take a moment and think about that. Really good. All right, so we need to, because like you're multiplying this thing by -8.3, multiplying by a negative generally makes things smaller unless you started with a negative, right? If this 5.5 minus t all squared were negative, then multiplying it by -8.3 would make it more positive. But we're actually looking at this component now because we're going to multiply that by -8.3, and -8.3 makes things kind of the opposite in sign and larger. What I actually want to do, that is the opposite of what I want to do. What I want to do is figure out a way to maximize this whole thing. Means I need to minimize what I'm going to multiply by -8.3. Okay, so one of the keys to maximizing values in functions is often to minimize the other part in the function, which seems counterintuitive. But we're squaring something here, right? We're squaring 5.5 minus t. If I can get, if that is a positive value in here, then when I multiply it by 8.3 with a negative sign, that's going to be like a value I take away that eats into this 300. So what I want to do is actually figure out a way to make this part 5.5 minus t squared as small as possible, so that when I multiply it by -8.3, the impact is lessened, right? So the smallest thing you can get 5.5 minus t squared is 0, because nothing on the GMAT squared is ever going to be negative. right? No imaginary numbers or complex numbers on the GMAT. So the smallest I can get this value into this updated blue rectangle is 0. And that happens when t cancels out with 5.5. So t equals 5.5 makes the squared term the smallest possible, which means when, it's a bad comma which, meaning, when you multiply by negative 8.3, the impact is lessened. We're trying to maximize this value. So anything you multiply by negative 8.3 potentially would eat into the 300. So if t is 5.5, that will max out the line. This whole thing turns to 0. And the longest the line can be is 300 people, 5.5 hours after the park opens. So the park opens at 9:30, 5.5 hours after 9:30, do some counting, is 3 p.m. Yes, so this is a very kind of conceptual problem. There's not a lot of math you want to do here. Someone told me in chat, they said, I liked it. This is a good one because you need to analyze the max point and not do any math. Yes, I'm all about not doing math on this exam. Remember, the M in GMAT does not stand for maths. And the A does not stand for algebra. If you're doing too much algebra and too much math, maybe there's another way to think about it. Cool. So when you see a max min problem, oftentimes the best move here is to try to minimize the stuff that would eat into the maximum or maximize the other stuff so that you minimize what's left. Like one of my favorite examples for this is like, suppose I'm on a 2,000 calorie per day diet. I need to eat 3 meals a day. We'll call them breakfast, lunch, and dinner. I must have 100 calories, at least 100 calories for each meal. What's the largest, what's the most calories I can allot to dinner? Yeah, and so what we want to do is like to max out what I can have for dinner, I need to minimize what I have for breakfast and lunch. So if I assign 100 calories, that's the least I can assign to breakfast. 100 calories is the least I can assign to lunch. I'll leave me with 1,800 calories for dinner. Sounds like a big dinner. All right, I have one more for us. This one, I had to think through this one a couple times when I made it. I hope it's a decent problem. I'm ready for there to be problems with it. If you think there's a problem with it, let me know. Here's the last problem of the day. Thanks for sticking around this long. I'll give you a couple minutes to think through it. Yeah, I couldn't let us go through a whole session without any data sufficiency. It's been a little over a minute. We're at 2 minutes. I'll give 1 more minute if you feel like you are close. If not, guess. Cool, that's been 3 minutes. Thank you. I'm getting a variety of answers. I'm getting every answer except answer E, which, to be honest, I think if you're going to guess, like, you definitely don't want to guess E in data sufficiency. I'm interested in knowing how people are getting started here. I think there's a couple of ways to get started. One might be to just assess, like, if we're going to invest much time in this problem at all and see if there's a way to strategically guess. And another method might be to actually start thinking through it and figure out how to solve loosely this problem. So let me know in chat, how are we getting started? Okay. Good, I'm hearing some good things. I'm starting with statement 2 because it looks easier, because statement 1, that looks absolutely awful. Might just completely random guess. I'm still stuck on the roller coaster question. That's totally fine. This whole prep hour has been a roller coaster. Statement 1 doesn't look sufficient because it's like an inequality. So inequalities don't give you values specifically. So maybe we don't like statement 1. Cool. I think we're going to start with statement 2 in a moment. I just want to talk through again what's happening in this function, because I think just kind of telling yourself what's going on is a good way to give yourself a little more confidence in case you are going to tackle it. So this function holds whenever x is an integer. Whenever I input an integer, I'm going to get a value transformed out. And so apparently there's different conditions when x is even or when x is odd. So maybe I'll just like try this quickly so I can understand the example. What if I take f of 6, like this, the ugliest 6 ever, but take my word for it, it's a 6. What happens with f of 6? Well, x is even in this case, so I'm going to use this version of the function. I'm going to take 3 times 6, and then I'm going to subtract 2 from it. 3 times 6 is 18, minus 2 is 16. So, okay, when f is 6, I get 16. What happens when I do f of 7? Well, now my input is odd, and so when I have an odd input, I square the input and then add 3. So that would be 7 squared plus 3. 49 plus 3 is 52. All right, so I've kind of walked through how the functions work in this case. All right, another idea was to go tackle statement 2 first. I like that because statement 2 does seem easier. And so let's see what statement 2 is telling me. I've got some like recursiveness in statement 2. I've got the function of f of 2. So again, this is similar to seeing multiple symbols in a function problem. You just want to remember your order of operations and kind of like work from the inside out, right? Start within kind of the most narrow parenthesis group and work from the inside out. So I'm going to take f of whatever f of 2 is. I should go figure out what f of 2 is. And then I can take that value and just substitute it in here. All right, f of 2. 2 is even. So what I do when I have an even input, I triple it and I subtract 2. So triple it and subtract 2. That's going to be 3 times 2 minus 2 Nice. F of 2 is going to be 6 minus 2, or 4. If f of 2's value is 4, then what I can do is just like say, I'm just going to get rid of this occurrence of f of 2. I'm just going to call it 4, because that is the power of the equal sign. Literally, f of 2 is the same as 4. So when I see it, I can just replace it with 4. And now I have to do x is equal to f of 4. Okay, well, if I plug 4 in to this function, 4 is even, so I'm going to triple it and subtract 2. That's going to give me a value, which means x has a specific value, and the answer has to be B or D, because statement 2 is sufficient. It tells me a value for x. And I think that's like really, really important to understand, like that this input, f of 2, has a value, right? A specific value of 4. And when we have a specific value for f of 2, that just means we're plugging that new value into the function again, and that will give us a new, potentially new specific value. So statement 2 is sufficient. Now we have to kind of make a business decision here, all right? Maybe we made a business decision at the very beginning that we were just going to skip this problem. Totally cool. Just don't guess answer E here. If we tackle statement 2 first, we see statement 2 is sufficient. Now we've gotten to a 50-50 shot. We make another business decision. Is this something I want to pursue? Okay. All right, the other way to proceed through this question, and we are going to tackle statement 1 because I can just imagine the angry YouTube comments if I do not talk about statement 1. I already think I'm going to get in trouble for not talking about that crazy one with all the stars, the Roman numeral 3. What I want to do here is focus on this. If f of x is 82, I want to think about like what that means. How can f of x be 82? Can we think about like what we could plug in here? What could this be to churn out 82? Comment came in, has to be even. Why? Why do we think it has to be even? Ooh, I don't think it's 26. 26 is close. Ooh, Akil, Kendra, nice. Ooh, I like it. Okay, good stuff. So let's see what happens. Suppose the question mark is even. All right, we don't know if the question mark's even or odd yet. Suppose it's even. Well, that would mean f of the question mark, whatever it is equal to 82, which is 3 times the question mark minus 2. I'm not using x because like I don't want to use x again in multiple ways. Okay. If 82 is equal to 3 times this unknown input minus 2, then I'm going to add 2 to both sides. I get 84 is equal to 3 times whatever this thing is. And now I can divide by 3 on both sides and say 28 is equal to the question mark. Yes, 84 divided by 3 is 28. Okay, well, maybe the question mark isn't even though. So suppose the question mark is odd. Well, then you'd have to go to this version of the function. F of the question mark is equal to the value of that input squared plus 3. And we're told here that it's equal to 82. Okay, well, how would that work? I would subtract 3 from both sides and say the question mark square is equal to 79. So the question mark is equal to square root of 79. That's not odd. That's not an integer. So actually, this situation is impossible. And I think that's what Jay was saying. Nice. Really, really good. Cool. All right, let me see if I can just move some of this down because I think I have animations. So what we know is this only happens if what's inside this question mark, what this question mark is 28. And what that question mark is covering up is f of x. So f of x has to be 28. Now we have to go through it again. What could x be if f of x is 28? Ooh, getting some good comments in here. I'm going to go ahead and get rid of this. Nice. Getting some good options. I love it. Good thinking. I want to run through these same things. Suppose x, this new input, is even. That means f of x, which is 28, is equal to 3 times x minus 2. That would tell me 30 is equal to 3x. So 10 is equal to x. But maybe x doesn't have to be even. Maybe x could be odd. Suppose x is odd. What happens here? Well, f of x is still 28, but now we apparently could get to 28 by squaring x and adding 3. Interesting. So which means 25 could equal x squared. And if 25 could equal x squared, what is x? Not just 5. Technically, it could be plus or minus 5. Yeah, those tricky. All right, so by looking at f of x is 82, that can only happen if our kind of next higher level input is 28. We can only get 28 as f of x if x is 10 when it's even, or plus or minus 5 when it's odd. So how could f of x be 28? That can only happen in these 3 instances, when x is plus or minus 5 or 10. So now this question, what's the value of integer x? What I'm going to do is I'm just going to add this extra stuff, the stuff we just figured out. Oh, f of x has to be 28, and x has to be negative 5, 5, or 10. Which one is it? Can we figure out which one it is? Well, statement 2 is already sufficient. We found that it was 10. But now we can look at statement 1. Guess what? In statement 1, I know my denominator already. I know my denominator is 28. Now I just have to figure out what this is. What is f of x? Well, I already know that this, yeah, I went a little too far there. I already know that this part, f of x, is 82. So what I can do is I can say, well, if it's equal to 82, it means like anytime I see f of x, I can just cover that up with 82. So what is f of 82? Well, it's even. Yeah, where did I get 82? I got it from right here. It's given. There we go. Plug in 82. It's even, so we're going to triple it. Triple 80 is 240. Triple 82 is 246. Minus 2 is 244. So this tells me that 244 over 28 is less than x. 244 over 28, just estimate that. That is about 9. Something around 9 is less than x. So x can only be 10 in these options. So statement 1 is sufficient here. Yeah, so I think one of the other things you can do in data sufficiency, if you're not going to guess E, same principle is we don't guess E because not knowing does not mean not sufficient. What we want to do is in general, guess that a statement is sufficient. Statement 1 is telling you information. You don't know how important that information is. So what we want to do is give the information the benefit of the doubt in general that this is going to be sufficient. It's not going to work 100% of the time, but in the long run, you will pick up some extra points by guessing sufficient and proving insufficient. So if you're on the fence between answers B and D here, in general, what I would say is if you're not sure about statement 1 because it's really kind of confusing, give it the benefit of the doubt and guess that it's sufficient. What do we think about that one? I spent a long time coming up with that one and making sure I understood it because it is itself confusing for me as well. All right, good stuff. Thank you for spending some extra time with me today. Thanks for going over, really appreciate it. I know your time is valuable. Just a reminder to come check out some other free options. We should be having more free GMAT prep hours coming up in the next few weeks. So check the schedule and hope to see you at a future event. Thanks everyone. I'm gonna go ahead and turn off the recording. If you have a few questions, feel free to stick around. Thanks for watching the video today.